And I know that the invitation said delay study. We're gonna talk about delay studies also, but for our purposes, we're going to focus primarily on downtime studies, and they're somewhat related, and we'll get to that in a minute here. You can also refer to Epicenter's newsletter from November 2007, where I do get into downtime studies. I might have called them delay studies in there as well. But some of the highlights of this class today are in there. So who do we have on the line today? So I heard some people from the Toledo area.
Yes. Mark, Chad, and Danielle.
Very good. And I've got, sounds like Sarah and Beth. And you can hear my dog in the background barking. Anyone else do we have on the line?
Chris is here.
And Chris. Very good. All right. So this is our course agenda for the day. There's some things, of course, we want to get accomplished. First question is, what are downtime studies? What are the expected benefits of a downtime study? How do we prepare for a study? How do we conduct a study? We'll get into summarizing the results, and I'll give you some examples of results from a downtime study. And finally, we'll talk very briefly about developing conclusions and recommendations. In other words, okay, once we've done a study, now what are we going to do with this information? This presentation is meant to be informal, so if you have a question, please stop me and ask your question. I don't think it's going to take the full hour to do this presentation. I think there's 14 slides or so, but and I'll be showing you a spreadsheet that I know that Chad and some others used on a project that we did a couple years ago as an example. But go ahead and certainly stop me if you have any questions, okay? All right, so what is the description of a downtime study? A downtime study is a method of identifying and quantifying delays or downtime associated with a person or a piece of equipment. So you can imagine if you're studying a person, you might be watching them to determine how often they're waiting for parts, how often they might be waiting for a supervisor or to get directions. And in many cases, if we're doing a study like that, it's more what I call, it's almost like a time study, but where we watch someone throughout the entire day from start to finish, and we're accounting for all their time. This is similar to a project we did in the past for Pilkington. It's called a delay study. So it's not necessarily just downtime, but it's looking at everything. And part of the results of that are to understand where the delays are. Specifically, another type would be for a machine. This is what we're going to be doing on our upcoming project. And we're looking at whenever that machine is not running. Why is it not running? Is it waiting to be repaired, or is it waiting to be fed with materials? And that's truly a downtime study. Why isn't that machine not running? And off here on the right, you can see a little picture. This is used for efficiency, operational efficiency, where you might say if I have a rated capacity of 100%, we lose some of our capacity from the equipment from preventive maintenance. That might be from preventable. These are things that we're doing purposely. Maybe we shut the machine down for 10% of the time for maintenance. But we also lose something from failure from breakdowns. Is another 6% we lost. We might lose from setup and adjustment time, so that might be another, in this example, another 17%. We might lose something because we're not running the equipment at its rated speed. Maybe we're running it slower, so we lose another 5%. And maybe there's some minor stoppages that occur. And this all basically contributes to what we finally get at the end, this reduced yield. So in many cases, when we talk about a machine's capacity at 100%, what we're really getting out the door is much less. And it could be as small as, well, in this example, 44%, but it's not unlikely, especially if there's a lot of changeovers, for machines to be only used a fraction of the time that they're rated for. And it's very difficult for us as industrial engineers then to figure out how much capacity we really have, because we have all these things that we're losing throughout the day. So the purpose of a downtime study is to really start to understand where we're losing those things. Where are we losing? And some of it's preventable, and some of it's not preventable maybe. Some of it's scheduled, some of it's not scheduled. What are some typical types of delays or downtime? I just have some different categories put together here. It could be a combination of things. There's certainly equipment reasons. They could be mechanical failures. They could be machine jams, machine timing not working. It could be a process or a method situation where you have poor labor methods, like a poor balance on an area, or maybe they're not running it timed out with the machine correctly. We have to do a man-machine chart. You could start to lose time on your equipment that way. Maybe poor planning, resources not available. Maybe the scheduler didn't plan the machines out properly, so some of the machines are sitting because they have nothing to do. Or maybe it's the people. We don't have people available because we didn't plan properly. Another type of reason for downtime would be people. Maybe they're not using proper methods, or maybe we don't have enough people. And then finally, again, these are just types of downtime. Materials. Maybe we don't have raw materials. We don't have enough raw materials. Or maybe the quality of the raw materials isn't good, and so it's causing a lot of downtime trying to get the machine to work properly. So if I look at this guy, he's about ready to step on a banana peel. You know, there's a lot of things going on here. I guess the first question is, why is there a banana peel there? And, you know, so that might be a process issue. Secondly, he's not watching where he's going. And typically when you see downtime, it's usually a combination of several things that are occurring at once. And it's a challenge to understand what the root cause of it is. And that's something we always have to try to get to. If you see a machine goes down, to really understand why that machine went down, you may have to go through a couple of layers. Like you might say, well, the person's not there, that's why the machine went down, but it might be that actually the machine's supposed to run even when the person's not there, and it's an equipment issue. So I think that's one of the things that we always have to do. When we do a study, we always have to try to get to the root cause of why the machine went down. Any questions about that? All right. What are the benefits of doing a downtime study? Well, I'm going to list two main benefits. One would be understanding capacity losses. Like we said, we have dripping water here. Why are we losing capacity? What are all the different reasons that we could be losing capacity? And I've had cases where, you know, they knew where they were losing capacity. They just didn't know what the impact was of those losses. So that's the second benefit, is it helps us to start to quantify how much you're losing from different things. And sometimes it can be a big wake-up call for people. I once did a project where they lost like 40% of their capacity because the operators were taking long breaks. 40% of their capacity. So now it's a big eye-opener. I think everyone knew they were losing capacity, but they didn't realize how much. The third question is, how often do losses occur? That's interesting to know. Do they occur throughout the day, or is it certain shifts or certain seasons? And what are the cause and effect of the losses? Like, why are these losses occurring? We might say the machine is down, but why is it down? Is it something else in another department that could actually be causing an issue? Did a project recently where there was a lot of changeover downtime in one department, and when I talked with the operator, they said the reason is because the previous department, when they were spooling up there were these giant metal coils, the end of the coil was always buried on that spool. So it took them like 5 or 10 minutes just to get the end of that spool unburied, so they could then, basically they welded it to the previous wire, and that allowed them to finish a changeover. And they said if the previous department didn't bury the end of the spool, then it would allow them to change it much quicker. And so that's one of those things where unless you talk with the operator and you observe the overall system, you might not understand. The second benefit, main benefit, is just the direct observation does improve understanding of the operation and the people. So numbers are great and spreadsheets are great, but actually being out in a department and watching it and watching how people work together and why delays are happening really does help understand. And sometimes that could be the biggest benefit. As industrial engineers, if we're going to help a company to improve their operations, we really need to have a good understanding of what's really going on the floor. So this project that we have coming up, I'm not going to mention the name of the company, but the project we have coming up, half the benefit of us being out there during those 5 days is really to observe what's going on and try to understand why do things happen. Anyway, that's a good benefit of anything. Anytime we do a study that's out on the floor, you're really getting an intimate understanding of what's going on when you're there for a long period of time. Any questions about the benefits? Before you go and do a study, I would always suggest doing some preparation, which would include spending some time out in the area to understand what delays do typically occur. That helps you set up your forms and kind of have an understanding of what you might be looking at. Helping to identify locations for where to best observe operations. Where should I stand? How am I going to be able to observe these things? Certainly introduce yourself to the people in the area if you can. Let them know that you're going to be out there doing a study. You don't want them to be surprised. Have cases where you go out and the people in the area weren't informed that you were coming, and then all of a sudden there's a big issue and the supervisors are involved. And you always want to make sure that everybody knows before you start doing anything that what you're doing, who you are, and answer any questions that they might have. These are good things to do, not the day of the study, but days before if you can. Creating a preliminary form with the typical delays, that's certainly something that would be helpful to do before you actually start to study. I think for this upcoming study we'll have some typical delays on the form, but we'll also leave spaces for new things that we haven't thought of yet. And then finally determining how the study will be completed and the logistics. So, when is the best time to study the operation? You certainly wouldn't want to study it if it's an unusual week, like there's something going on that typically doesn't happen. I was on a call with the supervisor earlier this week, and they said that the guy they regularly have run this one machine will be out the week we're going to be studying it. So he's going to have to substitute another person. Well, it's good for us to know that. We certainly wouldn't want him to substitute for somebody who really doesn't know what they're doing, because if we do a study with that person, then we might get results that aren't typical. So lots of things to make sure that when you go out there, you're getting a typical day with a typical person running a typical, production. Any questions about this? All right. Completing the study. Look at this guy on the right. What do you think? Would he make you nervous? He's got an orange tie on. I think that would kind of make me nervous, a little shiny. I would say, probably the most important part when you're out in an area completing a study is to have a friendly attitude. In some cases, wearing a tie or a suit or something that makes you very formal can actually be very intimidating for people. You don't want to go in. You want to kind of dress like the people out there, maybe a little bit nicer. I always suggest wearing Dockers and a button-down shirt or something, but short sleeves are fine if it's hot. But the goal is really you're not there to be a source of stress. You want to be out there as a person who's doing a study, have a friendly attitude, make sure you introduce yourself. I would say definitely get to the study area before the study starts, again, to introduce yourself and also get a lay of the land. So you do a review of how things are going and you ask them, how are things going? You want to make sure everything's going well before you get started. If he says, oh, geez, we had a big problem in the other upstream operation and we're not going to be getting any product this shift, or so-and-so called off sick, or you kind of want to get a lay of the land on how things are going before you actually start to study. In our case, it depends on how familiar you are with the area. Maybe you go 15 minutes or 30 minutes before the study actually starts. And then use the form to document the activities. And there's different types of forms. I'm going to show you two different types in a minute. One might be all the activities, which would be what I'd call a delay study. And typically, if you're studying one person, you might do a delay study. You're accounting for 100% of the time in a delay study. Okay, it's really like a time study, but it's very detailed because you're capturing all the time. Or if you're just looking at downtime, like in this upcoming project, you might do a downtime study where you could study one or more people and machines. In that case, you're not concerned about all the time. You're only concerned about the time when the machine is down. So those are the activities you're measuring. And then, of course, you can figure out all the other time, which is time the machine is running, by subtracting the total time from the amount of time the machine went down. You're going to document the conditions on the form. Where are you studying? what's the date, who's the person that you're studying. It's always good to get that in case later on you have questions so they know where that data came from. And then you're going to basically, whenever a machine goes down, if we're doing a downtime study, you're going to jot down the time that that element started and the time that it ended. And I like to use a watch with a seconds hand, but you could also use a clock on the wall. Certainly you would want it to be down to the second if at all possible. Sometimes you have very short downtimes. So you're going to be watching the operation. You see the element go down. You don't know why the machine's gone down yet, but you're going to jot down that time, the hours and minutes and the seconds on your form. While the machine is down, you're going to try to identify why the machine is down. And you're going to ask if you don't know. You don't want to guess. So if the machine's down because there was a fault, and I think they actually have some fault codes that we might be getting for this upcoming project. So if the machine has a fault, you'll write down the fault code. It's a machine issue.
Hey, Bill,
And then, of course, as soon as the machine starts running again, then you would put the uptime.
Hey, Bill.
If he's jogging the machine just to try to see if it's working, that wouldn't be considered running again. It's still trying to get it running. So you just have to use your best judgment on when the time, when the downtime ended.
Bill?
Yep.
Hey, on that topic, one thing I'd like to mention is while you're doing the downtime study and you're observing it's down, don't ask the operator necessarily during that time, because he's trying to get the machine back up and running.
Yeah.
You know, once the machine's back up and running, and you can see the operator has time then to answer a question or a maintenance man, because what you don't want to do is interfere with the downtime itself and create additional downtime by you talking to them.
Right. You want to put yourself in their shoes. So you're not trying to be in the way. So if when the machine is down, of course, their number one goal is to get that machine running again. So you don't want to impede their ability to do that. They're trying to figure out why the machine's down and trying to get it running again. So yes, that's a good point. And you certainly, if you just want to make sure that you don't let it go. So when the machine's running again, you do want to ask as soon as you can, and it's a good, reasonable time. You don't want to let it go because later on you'll forget what happened. Don't save up your questions until the end of the shift. You want to ask them once the machine is running if you can. Now, if you're doing a delay study, and I'm mentioning this because this kind of is the same technique for delay studies, but a delay study, you're going to be observing every single second. So if that's the case, you're only going to be putting in the time the new activity started, because the next activity that starts will be when the previous activity ended. It's a continuous 100% time, and I'll show you the form here in a second, but that's the difference. Downtime, we're only dealing with those downtime occurrences, which is the downtime and the time it went up, and then from that we can calculate the duration of the downtime. A delay study, we're basically saying every time some new activity starts, here's when it started, and then from that we can calculate how much time they spent doing various things. Again, I'll show that to you in a second. The other thing, and this is why we're consultants, and so we certainly have to get that data, but we also want to start to generate some ideas. And those ideas can certainly come from the operator or anybody. You got to get the data, but if you're out there and someone has some ideas, certainly jot those down. If you have any ideas for improvement, you want to jot those down, and usually there's a place on the form to put those ideas, or you can write them on a separate sheet. One of the deliverables for the upcoming project is a list of ideas that we came up with. So if you see a machine's going down a lot, one example you might say, gee, it took the operator a long time to identify that the machine was down. So one thing to consider would be a light or a warning signal, something that would signal the operator to let them know that the machine is down, so there isn't that much of a delay. Or maybe they're running around looking for tools. You might say, geez, they spent 5 minutes trying to find a wrench. Well, so an idea might be you need to have some tools that are dedicated to that specific workstation that are stored in a cabinet or something where they're easy to find. So I want you to be writing down those ideas, and we'll collect those, and then as we start to say, well, geez, that downtime represents 5% of their downtime, we can go back to those ideas and say what ideas have we come up with already that might help us to address that particular issue. So there's a couple different forms. This is an example of the form we'll probably use on the upcoming project. So these are different machines. So a machine, let's say this is the 800 machine. We're going to put the time that the delay or the downtime started. So this would be 3:23 and 50 seconds, and the time that it ended. And then we're going to have, this one isn't filled out, but you would put an X next to the cause, the column that had that particular cause. So maybe reason 1 was ran out of material, and reason 2 might be, on break. And we are going to measure, by the way, breaks and lunch. Anytime the machine's down, we're going to identify why it's down. It might be just not scheduled to run, so they shut it down. That would be a cause. And off the right here, you can see we have a place for notes. You might say consider a warning light, or maybe the person left the area. So this is an example of the form we'd be using. So you would just do each one as they occurred. You may actually have a couple machines down at once, so these times might intertwine. And then to calculate the duration, we're basically just going to take the end time minus the start time, and that's going to give us a duration in seconds. This is an example of a previous study that was done. I'm sure some of you are very familiar with it. This is more of a delay study. So a delay study captures every minute. So this activity, which is a run time, this code is run time, is the first column. It started at 7:08, and it went until 7:19:45, at which time there was a CP that occurred. It was a carton packer jam. And then the machine started running again at 7:20 and 50 seconds. You can see that this shows all the time. So this shows the run time as well as all the other things. Now you can see this is an example of a blank. We have a blank column here. So if you just are doing the study and you can't fit that downtime cause into one of these predefined categories, you could just go ahead and add in another category. I mean, really, these forms could be used any way you want. You could put stuff in the notes column if you wanted. But this is an example of what I would call it more of a delay study. This is a downtime study. This is a delay study. Any questions about this? Now, the reason we do it this way is because we can start putting in formulas. So by putting things in columns, we can start to put in formulas. And I'll just show you. This is a spreadsheet that had been put together before. Let's see here. So here's, oh, look, here's the exact data we're talking about. And then we have some nifty formulas here off to the right where it calculates the duration, and then it takes whatever the time was. There was no time for this first one. But this one, there was a time of 1.83 minutes. So it put it in the correct column based on where the little X was. And then what we can do then is at the top, we can total up all that time. We can identify how many occurrences happened. We know based on that what the average time per occurrence was, and we can calculate the percentage. So this LS, which happens to be the line starved, that occurred 5.1% of the time. It happened 10 times for an average of 0.7 minutes each time. We can also link that information to spreadsheets or to charts and things. I'll show you that in a minute here. But we already have spreadsheets like this that we can modify as needed for this particular study. That will be one of the things that we'll do early on is as we start getting data, we'll start to take these columns and finalize what they will be. And then as we get the data, we'll be able to just apply these formulas. And theoretically, we could do, after every shift, we could just take the data and, have graphs and everything. Now, one of the things that we're going to be doing on this upcoming project is using the FieldPoint software. It's going to give us some of this data, but it's not going to be quite in this format, but it's going to be just like a spreadsheet. So we'll have to create some special spreadsheets for that particular data. But again, using a spreadsheet is a nice way to summarize the data because if you have different machines, different dates, you can start to do different types of analysis and say, well, Monday, this is how the downtime occurred. but on Tuesday, the downtime was less. Why was that? Or maybe we find that there's more downtime on first shift than there is on third shift. You can help us start to slice and dice that data and try to understand maybe some cause and effect. Is there something specific that's going on in that manufacturing area that's causing downtime? We can start to correlate it to other things going on in that area. So we collect this information, we summarize information, and then here's some different ways to summarize. I already showed you this way, just like putting it into tables. We can certainly put it into pie charts. This is a very simple pie chart. 76% runtime, 24% downtime. And then we can also create things like Pareto charts. This is percentage of downtime. It's relative to this 24%. So 24% of the time was down. Of that, 65.4% of that downtime was related to the line being starved, and so on and so forth. So what's the benefit of having the data in a Pareto chart like this? Anybody?
Tells you what to attack first.
Yeah, it helps you kind of prioritize, right? And you know if you fix this box turner, the most you're going to get from a benefit is 5.7%, right? But line starved is huge. So you might say, geez, that line starved, that it seems like we could just reduce that by 20%. That could have a big impact. So it helps you not only prioritize where to focus, but also quantifies what the benefit might be.
It also could help you justify paying for changes.
Yeah. So if you're losing 12% from your case packer, that might be a good justification to improve your case packer or put in a preventive maintenance program, which costs money, or maybe buy a new case packer, or maybe buy an extra case packer. You can start to create relations between how much you can get out the door and what your savings are, what your profit is, and you can start to justify some of these purchasing equipment or putting new programs in place. Here's some other ways. I can imagine that for this upcoming study, here's how we might show the data. It's a stacked bar. So the running percentage is 65% in this example, and then these are sorted by worst to best. So changeovers represents a certain percentage, and equipment jams, and no raw material, and so on and so forth. You could see the time adds up to 100%. It kind of helps you see visually where your big slices are. You could do something like this, or you could do a pie chart. And then, of course, this is the one I showed before. This is more indicative of, I think it's called an EOO or EEO. It's an equipment operations efficiency, where you say, okay, your equipment, at what efficiency is it running? And you start to look at all these other factors. And certainly if you're going to do bottleneck analysis and you're looking at how do you improve the capacity of a bottleneck, a lot of these things are part of that. Like, what can we do to make sure the machine always has raw material? What do we do to make sure it always has a place to put its finished product? What do we make sure to do that it gets changed over quickly? The bottleneck operations, which my understanding is these machines we're going to be studying are bottlenecks. Anything we can do to keep that machine running, whether it's reducing unplanned downtime or planned downtime, anything we can do is going to directly impact their sales, because it's the bottleneck. Everything has to go through that machine. So it's sometimes whatever of these different methods kind of rings or resonates best with a group. They're all just visual tools to help them see. I've always liked Pareto charts. I like stack bars too. This might be a little more challenging for people to look at, but it's a good way of showing how little things add up. 7% here and 5% here. It all adds up to a very large percentage at the end of the day. All right, well, believe it or not, this is the last slide. So once we have done a study, it's not enough to just do a study and give results. We have to give conclusions and some sort of recommendation. It's not enough to just to collect the data. We have to do something with it. And I think that's the important thing to keep in mind here, is we might give them the best data and the most accurate data that's humanly possible. But if we can't actually take that data and do something with it, then the value of the study is really diminished. So the question is, what can we do with the data? So some of the things that we can do with the data. One, we talked about this before, the results from the study can help us to quantify the impact of various causes of downtime. Where should we be focusing our efforts? And if we do a cost-benefit analysis, so cost-benefit analysis would be say, okay, if I improve this machine in this way, what will be the savings? I can calculate what the cost would be to implement it, so what's the benefit? So you can imagine that this type of analysis will help us understand what that benefit is. So maybe you say, if I put an automatic loader in this machine, I can eliminate all the delay because of loading delays. So what is that worth to me? I know the cost of that automatic loader is, $25,000, and I know the benefit is I'm going to get so much more production. I can start to quantify what that extra production means in terms of benefit savings. And that allows you to do things like payback analysis and rate of return, rate analysis, and justify some of these different costs. So that's probably the number one benefit you can get out of a study like this. Second thing is the study notes that you get. Again, while you're out there, you're as an industrial engineer, you're not just a data collection person that's just standing there collecting data. You're also thinking about, if this was my operation and I was running this or I was doing this activity, how would I improve it? So those study notes and things that you come up with, in addition to further discussion, we'll have discussions about those notes after the study is over. We'll have discussions with the client, and we'll take those and add those into the results, and they'll help us to start looking at how we can come up with solutions that are sustainable. So if we come up with, okay, the number one reason we have downtime is because there's a machine jam, and you have a bunch of ideas, things that you saw or ideas that you got from the operators that we can use to try to solve that problem, that's got a lot of value. So again, I want to just stress, and to me, it'd be deadly boring to be out watching an operation for 5 days solid just to collect some numbers. It's really about collecting the numbers, yes, but also starting to think, as an engineer, what are we going to do differently? How are we going to improve this? And certainly enlisting people that are there also. A lot of times the people on the floor have lots of ideas. They may not know how to articulate them, or they don't know how to justify them, but they're good ideas, and they can be worth a lot of value. And then the last thing is the results from these studies can also be used as a baseline to track improvements. So if we do a study for a client and we say, okay, here's your uptime, then we can certainly, if we have a list of improvements we're going to implement, we can certainly make a case to go back again in 6 months and do another study and see just what the actual benefits were and, what's the next place to take this. I really think as an industrial engineering firm, that's the ideal. We can have clients that will call us for these studies, and we can start to help them make improvements and go back on a regular basis to fine-tune or further improve, and that's a great partnership because, there's always good intentions. We're going to make all these changes, but at the end of the day, you're not going to be able to be as effective in those changes as you thought. I mean, in human nature, things tend to not go as ideal. So this becomes a nice baseline later on to look at improvements that have occurred over a period of time. Does anybody have any questions about this?
Just one question, Bill. This is Chad. What's your general thoughts as to how big a sample size you need to get accurate information from the study?
I think a lot of it depends upon how much variation there is in the system that you're studying. I mean, obviously, if it's something that's very routine, the same thing happens every day, then you don't have to get a lot of, it's really very much like time study. If things are fairly consistent day to day, then you probably could study one day and you'd be good. And I'm a firm believer in the idea of scalability, and that's why when we do productivity studies, I always feel like the data that we get, even though we're only capturing a percentage of the time, is scalable to the overall time. So for something that's pretty consistent, I think you could do a day. But if it's something that has long cycle times where you might be running one thing for 5 hours, well, obviously a day wouldn't be enough because you might not see a lot of changeovers. You might not see a lot of the typical activities. So then I think you start looking in terms of days and weeks, maybe a week. And I would suggest that what we would probably do is we'd say based on what we see, we're going to put together a base of what we think it will take, and we would take the results of that, and that would help us to understand whether we have enough, whether we really captured. Because if you got the results, and the results showed that your machines run 90% of the time, but you look at historical production, and those machines are really only running about 70%, then I think you would say, geez, you know, we must have missed something. That must have been a particularly good week, or we didn't watch it long enough. So again, I think the big criteria is how much variation there is in the process and how long those cycles are. And that would be the same criteria I would give to doing a time study as well. You know, statistically, the shorter the cycles, the less observations you need, and the more variation, the more observations you need. Does that answer your question?
Yeah, makes sense.
Okay. What other questions? Any other questions?
Nothing here in Toledo.
All right. Well, again, this is not a complicated tool. Like so many things we do, the tools themselves are not complicated. I think the key is how do we enhance it as an industrial engineer? How do we take the results of that tool and the time that we're out on the floor, and how do we get the most benefit for, you know, our clients? And I would challenge anybody out on a study like this. Again, I always, you know, I still go back and do time studies, and I still do delay studies. And, you know, if it was just about collecting the data, I think I'd have to say, geez, is there any value? But I'm continually surprised at what I see when I'm out on the floor and how it really does help. If you're in the frame of mind of looking at it as, this is my operation, how would I improve it? If I was working in this company and I was the engineer and I was responsible for improving this operation, what can I do with this data? I think there's just a wealth of information you can get. Even people that work within companies often do not spend time out on the floor looking at what's going on. And sometimes just spending the kind of time we spend out there, you can really develop a very good understanding of how things are really working. So I would challenge you to take this very simple tool and, you know, keep the tool simple, but, you know, make sure that you're using your brain when you're out there and really looking at it. And I think the observation part of this is really a strong part of why we do these. Even if the delay study didn't tell them anything, being out there has a lot of value for us helping and coming up with the solutions. So, all right. Well, if there are no other questions, then I guess I'll close this training. I'll be sending out a questionnaire to all of you for some feedback on it, and we'll certainly put this in our library of training that's available. So with that, I'll say